Welcome to part 2 of our live training session here with our K24 swapped Civic Si. This training module, we're going to continue on with our base map creation process, learning how we can set up our 2-dimensional and 3-dimensional tables so that we have proper fuel, spark timing, variable cam control, and everything needed in place to get our engine to fire up and run and have a successful calibration process with our EMU black. Without further wait, let's jump in so we can check this out. Welcome back to our live training session here with our K24 swapped Civic Si. This training tutorial, we're going to jump into our base map creation process once again, learning how to set up our 2-dimensional and 3-dimensional tables here in our MaxxEcu. These are going to be things like our fuel, spark timing, variable cam control, lambda control, and many more tables. Let's jump in here and take a look with our base file that we have loaded into the Max right now that we were working on that last tutorial. Let's jump in here and take a look at some of the fundamental tables we need to configure and set up first. Then we'll talk about some of the other background tables we might need to worry about and configure and set up. So the first thing we're going to do here is jumping right into my Max software. You can see ECU online. I have my ignition key powered on, the engine's not running, so I'm key on engine off, and I'm connected to the Max with my laptop. I'm going to move right here from my start area all the way down here under tuning. I have 3 main tables that we need to set up and configure: fuel, lambda, ignition. So these are the 3 biggest 3-dimensional tables that we have to make sure are right before we can fire up our engine. So let's jump in here to refuel and let's talk about this. Now, first things first, before we move into editing or doing anything here within our table, you're gonna probably notice that the map pressure here is reading in kPa and not PSI. I changed that before I started this tutorial because I usually work in terms of kPa when I'm looking at our map pressure reading. I like to work in units of Fahrenheit for temperature reference, but map pressure I usually work in kPa. I changed that up here under configuration under our MTune settings. I simply changed my pressure here to kPa instead of PSI, just to give you a perspective sake here. Moving in, if you're following along the last tutorial, you might be wondering why the map pressure here is now reading in kPa rather than PSI. Okay, so moving into our table here, we need to make sure that we have a few things sorted out. Very first thing is the breakpoints. Are the breakpoints going to be representative for the engine that we're trying to control and tune? So what does that mean? It means this is a naturally aspirated engine. We're not going to go above atmospheric pressure. So we don't need the table scaled out here to really above 99 kPa, 100 kPa. So our upper portion of the table, this is never going to be used on our naturally aspirated engine. What we can do here is change our breakpoint axes to get more resolution in our table and have more usable data points to hit and calibrate our engine with. So we don't have to worry about going in here and characterizing positive manifold pressure when we're never going to reach it. Now, also taking a look here under RPM, we need to stretch this table out much above 7,000 RPM. We're going to spin this engine out to about 8,500 RPM. So we need to make sure the engine breakpoint axes represent the rev range that we plan on bringing our engine to. So in my case, it would be about 8,500. Let's go in and configure this first. Then we're going to talk about our table values. How do we get proper volumetric efficiency values? And then we'll talk about another layer of tuning that we're going to go and configure, and that is going to be for our VTEC engagement. We actually have to have 2 tables, the 2 volumetric efficiency tables, one for low cam and one for high cam, and I'll explain how that works here as we go on. So let's go in here and we're going to right click onto our axes here. We're going to go into rescale axes. We want to keep it on map pressure as the input here to the table. When we go in here, we see the lowest value reading from the map sensor will be 20 kPa. I'm going to change that to 0. The highest value I'm going to put here to 110 kPa. I'm going to go a little bit higher than atmospheric pressure, just in case to get a ram air effect as I'm driving around from the intake setup that I have running here on my engine. So we can get a ram air effect and actually have positive manifold pressure. We want to be able to account for that. So what we can do here is change the number of cells we have. In this case, there is a total of 11 cells. The cell division is going to be 11 here. Let's change our cell number to something like 14 and the cell division to maybe something like 6. So if we have 6 cell divisions, we have 19 total cells. Let's see what that looks like and click OK. So now we can see we have a lot more resolution in our table. We go from approximately 108 to 0 kPa. So we have more usable data points to be able to tell the Max how much airflow estimation we have coming into our engine. Now, just as we changed our breakpoints here for our axes, what we can do is change our breakpoints for the map pressure. We can change them for the RPM. Let's go and do that real quick. So we're going to go here to our RPM. We're going to go a little bit higher than atmospheric pressure, just in case to get a ram air effect as I'm driving around from the intake setup that I have running here on my engine. So we can get a ram air effect and actually have positive manifold pressure. We want to be able to account for that. So what we can do here is change the number of cells we have. In this case, there is a total of 11 cells. The cell division is going to be 11 here. Let's change our cell number to something like 14 and the cell division to maybe something like 6. So if we have 6 cell divisions, we have 19 total cells. Let's see what that looks like and click OK. So now we can see we have a lot more resolution in our table. We go from approximately 108 to 0 kPa. So we have more usable data points to be able to tell the Max how much airflow estimation we have coming into our engine. Now, just as we changed our breakpoints here for our axes, what we can do is change our breakpoints for the map pressure. We can change them for
And let's click here. Let's right click and let's go to rescale axes. So we're going to start our axes off here at 0 RPM, and we're going to go out to 9,000 RPM. Now in this, change the number of cells, we can see here the cell division. This is how much RPM change per cell is going to happen. If I want to have 500 as my cell division here, we can play with the numbers here a little bit. 19 cells gives me a 500 RPM cell division. We click OK here, and we can see what that looks like. So 0 now to 9,000. This gives me a broader RPM range that I can properly characterize my feeling to my engine for this high revving K-Series engine. Now, let's go back in here and just quickly change our map pressure reference. I just want to go back into rescale.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.